Here we have section 10.2, measuring angles and arcs. So there's our main ideas, vocab. You can read those yourself. Okay, so start, you have a central angle, has the center of the circle as its vertex, and its sides contain the 2 radii of the circle. So what that means, if you look at the figure down here, so angle 1, 2, and 3 are all central angles. They have their vertex at the center, and radii make up the sides of the angle. Now the thing about circles is they have 360 degrees total, which means all of the central angles, however many you have to add up to 360. So if you have half a circle, they have to add up to 180. If you have a quarter of a circle, they have to add up to 90. So example 1 down here, for circle O, so find measure of angle AOD. So before I can do that, I need to find the value for x. Now I have AOD, DOC, and COB, and they make up half of a circle. AB is a diameter, which means that I can add them all together and set them equal to 180 degrees. So that would be 30x, 25, 28, 29, 30. So x is 6. Then I can just plug it back in. So measure angle AOD is equal to 25x, which is 25 times 6, or 150 degrees. The central angle breaks a circle up into pieces called arcs. One is inside the angle and one is outside the angle, but they are still both referred to as arcs. Now you have 3 types of arcs. You have a minor arc, which measures less than 180 degrees and is named by just the endpoints, so arc AC here. So endpoints there. The measure of the arc is the same as the measure of the central angle. So here the angle is 110, so the arc is 110. The other kind is you have a major arc, which is greater than 180. So here we have arc DFE. So the letters are the endpoints, so D and E, with another point on the arc. Now if you just use 2 letters, you go the shortest distance. If I just said arc DE, that's that way. DFE tells me that I have to start at D, go through F, and back around to E. Now it's still equal to the measure of the central angle, but for arc DFE, the central angle is actually 300 degrees, because if that part's 60, this part is 300, the other part of the 360. And then the other kind you have is the semicircle, and that's an arc that's exactly 180, so it's half of a circle, typically named with 3 letters as well. So here you have JKL and JML, but they are always equal to 180 because they are semicircles. That's half of a circle. All right. So theorem 10.1 here. In the same or incongruent circles, 2 arcs are congruent if and only if their corresponding central angles are congruent. So if 2 arcs have the same angle, they're equal to each other. 10.1 or postulate 10.1 here is the arc addition postulate, which is just like the segment addition postulate. It just says that you can add 2 segments together to get the total thing. So PQ plus QR is the same thing as PR or PQR. Okay, so example 2 here. So before we start, I'm just going to go through and fill in all of the angles, because then I can just look at my figure and don't have to keep calculating, stopping to calculate and going back and forth. So the first one I know is this one right here. That's a right angle, so that's 90 degrees. Now I also know CFD because that's half of a circle. That's 50, that's 90, so this has to be the other part of the 180. So these 2 together make up 140, which means this one has to be 40. I can find BFE because it's vertical to DFA, so if that's 50, that's 50. And lastly, AFE, once again, this is half of a circle, so it has to add to 180. If that much is 50, that part is 130. And now I'm just going to go through and answer my questions. So BE is 50. CBE is a sum of these 2, so that's 140. And ACE starts at A, goes through C, and around to E. Now there's actually 2 ways to approach that one. You could do 50 plus 40 plus 90 plus 50. Or if you notice here, you're only missing this wedge here, AFE. So if I take 360 minus AFE, I get the same answer, 230 degrees. So example 3, I'm not going to do any calculations on this one, just want to talk about it. It's really hard to see the different color wedges, but the central angle for each category. So for example, for Caucasian here, if I want to find the measure of the central angle, the circle has 360 degrees. I'm going to multiply by the 67.8%, but you have to convert it to a decimal. And you can do that for all the wedges, and that would tell you what this one is. So this one is 244.08 degrees. You just repeat the process for all the categories. All right, example 4, find the length of QR. So arc length is calculated using this equation. It's actually on the next page. So it's your angle divided by 360 is equal to the arc length divided by the circumference. So I need to find the circumference before I can start the problem. Now on this circle, the radius is 15. So for this circle, the circumference is 2 pi r, using this equation because I have the radius. So that's 2 times pi times 15. That's 30 pi. If you want pi as a value, you can leave it like that. I am, because it's going to make me not have to have decimals. So to set up my fraction, my angle is 120 over 360. L is my unknown. And my circumference is 30 pi. Now I'm going to reduce that first. That's 1/3. And then do cross products. So that's 3L is equal to 30 pi. So L is 10 pi once you do your division. And I believe the last slide, yep, is just the thing I just talked about. It's the formula for the previous example. And that is the end of the section.